Hello students. So today we are going to solve class 12th mock test 9. So let us begin with the first question. So first of all, see what is this question saying. It is the conversion of acetophenone to benzoic acid. Okay. So if you see, then we have acetophenone. This is the acetophenone. And we have to see its conversion to benzoic acid. Okay, so this with COH group is benzoic acid. So now what is this type of reaction? So this is basically an oxidation reaction. Okay, if you look at this reaction, so when we use an oxidizing agent, like I can use over here CaMNO4. Okay, so a strong oxidizing agent like CaMNO4, it can oxidize acetophenone to benzoic acid. Okay, so this type of reaction involves oxidation. So first option is the right for this question. Now we will see the next one. Next one is diazonium salts. They are primarily used in synthesis of. So if we talk about aromatic diazonium salts, so if you see over here, then we have this N2 plus and Cl minus ions. So when I take aromatic diazonium salts and if I treat it with phenols or aromatic amines, okay, or with aromatic amines, then they undergo coupling reaction, okay, and they form azo compounds in this case. And azo compounds, if I say, then they are brightly colored and which are basically used as azo dyes. So if I give you an example, then here is a diazonium salt. If I treat it with amine, which is this amine, okay, in a acidic medium, so it will give us a azo compound, okay. That is, if you see here, then this is nitrogen. Okay, and here is this NH2 group which is attached. Okay, so when you treat aromatic diazonium salts, they undergo coupling reactions with aromatic amines or phenols to form azo compounds. Okay, so the correct answer for this question will be B1, that is azo dyes. So these azo dyes, they are basically bright colored. Okay, they are brightly colored. Now let us see the next question. In next question, it is saying that the reagent which is used to distinguish between primary, secondary and tertiary amines. Okay, so you have to tell a reagent in this case. So for this question, if I say then HNO2, which is the nitrous acid, okay, then it reacts differently with primary, secondary and tertiary amines. Okay, if I take example of a primary amine, if primary amine is reacted with nitrous acid, okay, in presence of NaNO2 plus HCl, then we get a diazonium salt, okay, that is N2 plus and Cl minus, okay. And this diazonium salt, which is unstable, it further liberates nitrogen gas and forms an alcohol. Okay, so this is how HNO2, which is nitrous acid, reacts with a primary amine. If I take example of a secondary amine, then with secondary amine it forms N-nitrosoamine. Okay, N-nitrosoamine. Okay, and if I talk in case of tertiary amine, then in tertiary amine, okay, this reacts differently with tertiary amine. So it undergoes no reaction under cold condition. So the correct answer for this question is HNO2, which is nitrous acid. So first option will be the right one. Now next question is, which of the following correctly describes the structure of amines? Okay, so if I say the structure of amines, then you will see here nitrogen which has a lone pair and this hydrogens. So if you see this structure, then this is a pyramidal structure. Okay, so the correct structure which describes amine is the pyramidal structure. Usually you may feel it like it's a tetrahedral, but because of the presence of lone pair, it is pyramidal structure. If I talk about bond angle, then usually bond angle of tetrahedral is 109.5 degree, but in case of this amines, this is not the bond angle. Okay, the bond angle is slightly less, which is around 108 degree. Okay, this is because of the lone pair and bond pair repulsion. Okay, lone pair and bond pair repulsion, so it slightly pushes it inwards, and the bond pair the bond angle is less than 109.5 degree, so it is around 108 degree. Okay, so the correct answer for this question is pyramidal. Now we will see the next question. Now next question, it is saying you have to tell the highest, which of the following acids have the highest pKa value. Okay, now one thing which you all need to know, that if the pKa value is high, higher the pKa value, weaker will be the acid. Okay, so if the pKa value is high, then it will be a weaker acid. So if I talk about trifluoroacetic acid, then its pKa value is around 0.83. If I talk about benzoic acid, it is 4.19. Okay, if I talk about acetic acid, it is 4.76, and if I talk about phenol, it is nearly around 10. So if you see phenol, it has the highest pKa value. Okay, so in this case, phenol will be the least acidic. Okay, this is when a hydroxyl group is directly attached to a benzene ring. This is a case of phenol. And in this case, if you see trifluoroacetic acid, it has the lowest pKa value, means it is a very strong acid. Okay, if you see trifluoroacetic acid, if you see over here, 3 electronegative fluorine atoms are attached over here. Okay, so this is quite acidic. So the correct answer for this question will be phenol. That is fourth one. Now let us see the next question. Which of the following statements about carboxylic acid is correct? Okay, so if you see, then all carboxylic acids are liquid at room temperature. No, this is wrong. Carboxylic acids have lower boiling points than alcohols of similar mass. This is also wrong. Okay, carboxylic acids, they have higher boiling points as compared to the alcohols of similar molecular mass. Okay, carboxylic acids form dimers in vapor phase. Yes, this is absolutely correct. Next is higher carboxylic acids are soluble in water. This is also wrong. So the correct option is C option. So if you see over here, if you look at the structure of carboxylic acids, then this is one molecule of carboxylic acid, and here I am taking another molecule of carboxylic acid. This is double bond O. Okay, so if you see over here, this exists in the form of a dimer in the vapor phase. Okay, so if you see over here, there are two hydrogen bondings that are happening. One is this and one is this. One is between this carbonyl oxygen and the hydrogen of another carboxylic acid, and one is between this oxygen of this carboxylic acid and hydrogen of this. Okay, so if you see, they exist in the form of dimers in vapor phase. So if you see, this oxygen is partially negative, this hydrogen is partially positive. Here also, if you see, this hydrogen is partially positive and this oxygen is partially negative. So in this case, the correct option will be the third option. Okay, that is, exist in form of dimers in the vapor phase. Now let us see the next one. In next one, it is asking, in hydrogen bonding of RCOH, which is a carboxylic acid, with H2O, in protic solvents, in aprotic solvent, which atoms is primarily involved? So if you see over here, in case of hydrogen bonding with H2O, then the acidic hydrogen, if you see, then from this COH, this acidic hydrogen, it forms a hydrogen bond with the oxygen atoms of H2O molecules, okay, especially in the case of aprotic solvents where such interactions are prominent. So if I give you an example, then this is a carboxylic acid, okay, and you see this hydrogen of carboxylic acid, it forms a hydrogen bond with the oxygen of the water molecule. This is a hydrogen bonding, okay. So if you see, this oxygen is partially negatively charged, and this hydrogen over here is partially positively charged over here, okay. So the correct option will be hydrogen of COH and oxygen of H2O, okay. So in this case, the right answer will be second one, okay, that is oxygen of COH and oxygen of H2O, okay. Let us see the next question. Now next question, it is saying which compound can be converted to benzoic acid via oxidation using potassium permanganate, which is followed by acidic workup, okay. So if you see over here, if I take ethyl benzene, this is ethyl benzene, to this benzene a ethyl group is attached, which is CH2 CH3, okay. So when ethyl benzene, it is treated with KMNO4, okay, if you take alkaline KMNO4, then first it forms potassium benzoate, okay, that is this COK group is attached, and further when you do the acidic workup, you get a benzoic acid, okay. So if you see over here, this alkyl side chain, it is oxidized to carboxylic acid, okay. So in this case, the right option will be ethyl benzene, okay. So ethyl benzene, it can be converted to benzoic acid by oxidation using KMNO4 followed by acidic workup. Now we will see the next question. Which reagent is required to convert bromobenzene to benzoic acid? Okay, so it is bromobenzene to benzoic acid. First, let us see for bromobenzene. If you see, to this benzene, a bromine is attached, okay. So first, when you treat this bromobenzene with magnesium in the presence of ether, first you get phenyl magnesium bromide, okay, that is this Mg plus and Br minus, okay. When you further treat it with CO2, then you see over here, you get this C double bond O, and to this oxygen, your MgBr gets attached. And further, when you do the acidic workup, you get a benzoic acid, okay. So this is the overall reaction. In this case, we are using Grignard's reagent, okay. So the correct option will be Mg dry ether, which is followed by CO2, okay. So this converts bromobenzene to benzoic acid, okay. So the correct option will be second option, okay. Now let's see the next question. Next question, it is saying phenylethene, which is also called as styrene, it can be converted to benzoic acid by. So if you see over here, then to this benzene ring, you have CH2 double bond CH2. So this is phenylethene, or you can also call it as styrene, okay. So when the styrene is treated with KMNO4, okay, we take the basic medium, then first you get potassium benzoate, okay, and further when you do the acidic workup, you get benzoic acid, okay. So in this case, what will be the right answer? It is oxidation with KMNO4 under acidic conditions, okay. In this case, styrene can be converted to benzoic acid, okay. So the correct option will be third option. Let us move to the next question. Next question, it is saying, what are fatty acids? So fatty acids, they are higher members of aliphatic carboxylic acids. Okay, from which is ranging to carbon C12 to carbon C18. Okay, which is commonly found in natural fats as esters of glycol, as esters of glycerol. Okay, so if you see over here, the correct option will be third option, that is aliphatic carboxylic acids with 12 to 18 carbons. Okay, so the correct option will be third option. Now let us see the next question. In next question, it is asking which of the following statement about carboxyl group is correct. So if you see in case of carboxyl group, then what happens? The resonance in carboxyl group, it delocalizes the negative charge. Okay, we know that in carboxyl group there is resonance. This is C double bond O and OH. Okay, so if this goes here, you see the resonating structures. Here this O has negative and over here OH. Okay, this oxygen has lone pairs when it goes here. So this is CO minus double bond OH plus. So if you see over here, this is the resonance in carboxyl group. Okay, so it delocalizes the negative charge, which stabilizes the structure and it reduces the electrophilicity of this carbonyl carbon, of this carboxylic carbon. In case of carboxyl group, it reduces the electrophilicity of this carboxylic carbon as compared to a typical carbonyl carbon. Okay, so in this case, the correct option will be third option. That is, resonance decreases the electrophilicity of the carboxylic carbon. Okay, so this will be the correct answer. Now we see the next one. In next one, it is asking how many carboxyl groups are present in tricarboxylic acid. So if you see over here carefully, this tri is coming. So this tri itself indicate that 3 carboxylic groups are present. Okay, so if you look at the structure, then this is the structure. So if you carefully see over here, we have 3 carboxylic acids, 3 carboxylic groups which are present. Okay, so in this case, the correct option will be third. Even if you don't know the structure, if you see tri is coming, so itself you can say that we have 3 carboxyl groups that are present. Okay, now let's see the next one. Which carboxylic acid is derived from the Latin word for ant? Okay, so if you see over here, then the correct is formic acid. So if I talk about formic acid, then in formic acid, the Latin word which is formica, and formica means ants. Okay, so it was first derived from red ants. Okay, so the correct answer will be formic acid. Okay, so if you see, we will see select the second option. Now let's see the next one. Next one, it is saying which of the following IUPAC name for this compound. Okay, so if we carefully look, if we select, then this is the longest carbon chain, of course. If I do the numbering, then I will start with this carbon. So 1, 2, 3, 4. So 4 carbon atoms are there. So if there are 4 carbon atoms, the root word is butane. Okay, and if we are naming a carboxylic acid, then E of alkane is replaced by OIC, that is oic. So in this case, the correct answer will be butanoic acid. Okay, so remember, whenever you are naming a carboxylic acid, the E of the butane is replaced by oic. Okay, so the correct option will be butanoic acid. Okay, let us see the next question. In next question, it is asking what is the correct structure of ethane dioic acid. So if you see over here, again di is coming. Di means 2 carboxylic groups must be present. Okay, so the correct structure will be this of ethane dioic acid. So if there are 2 carbon atoms, the root word is ethane. And since its di is coming, that means 2 carboxyl groups must be present. Okay, so the correct option will be second option. Okay, if we choose then ethane dioic, the correct structure will be this. Now let us move to the next question. Next question, it is asking that what is the primary use of acetaldehyde? So if I talk about acetaldehyde, then in this case, the primary use is starting materials for polymers and drugs. Okay, so acetaldehyde is primarily used in the manufacturing of acetic acid. Okay, or I can say in the manufacture of polymers or drugs. The correct option will be starting material for polymers and drugs. Okay, if I talk about perfumery, then for it we use benzaldehyde. Okay, for preserving specimens we use formaldehyde, and for industrial solvents we use acetone. Okay, so the correct option for this question will be B1. Now let's see the next one. Next one, it is saying which compound is used to prepare bakelite. Okay, so in this case, when formaldehyde, which is HCHO, when it reacts with phenol, then in this case it forms a bakelite. Okay, this is OH, CH2, OH. Okay, so this is a bakelite. Okay, so formaldehyde, it reacts with phenol. This is a phenol to form bakelite. Okay, so in this case the correct option will be formaldehyde, which is B1. Okay, this is also known as bakelite, is also known as phenol formaldehyde resin. Okay, phenol formaldehyde resin. Okay, now let's move to the next question. So the correct option is formaldehyde. Now let's see the next question. It is, which of the following is a use of formaldehyde? So right now I only told you formaldehyde is used for preserving biological specimens. Okay, so if it is used as formalin, okay, formalin, which is 40% solution, which is used to preserve biological specimens. Okay, if I talk about use in perfumery, then that is benzaldehyde. Okay, and starting material for acetic acid, it is acetaldehyde in this case. Okay, so the correct option will be A1, that is preserving biological specimens. And if we see the last question, then what is the group which is present in carboxylic acid? It is very simple. It is COOH group which is present in carboxylic acid. Okay, CHO is present in aldehyde. Okay, so the correct option will be second one, that is COOH. Okay, so this is the correct option for this question. Okay, so here we have completed the mock. Okay, so these are the questions which we discussed. I hope the questions are clear to you. Okay, thank you students for attending the lecture. I hope the questions which we discussed are clear. Thank you.